Okay, so taking a look at the second part of the reasoning with angles and triangles, where we're going to look at angles associated with parallel lines. So, when we look at the definitions, parallel lines and a transversal on a diagram, parallel lines are often marked by arrows, which we can see here and here to indicate that they're going to be parallel. A line that crosses parallel lines is called a transversal. So this line that is running across both the parallel lines is my transversal. When a transversal intersects parallel lines, there are several relationships between the angles that are formed. So, first we can take a look at these corresponding angles, which we frequently refer to as F angles, because it's going to make a funny shaped F. So if I was to take a look at our example here, for the first part, I could say that here's my F angle. And you can see that it sort of looks like an F. The dashed lines were all drawn using a ruler and a set square. The dashed lines are parallel, which means that this, and this are all going to be parallel lines. Or we could put those arrows to indicate that they're all parallel. The marked angles are copies of the angle in the set square. If I measure all the angles marked, are they equal? Which means is this angle the same as this one, the same as this one, the same as this one? And the answer is yes. They are all 45 degrees. So, any pair of parallel lines makes an F shape with a transversal that crosses them. The angles marked A degrees are called corresponding angles, which means that the angles inside of that F are going to be corresponding angles. On the diagram below, mark 3 other pairs of F-shaped corresponding angles that we can have. So I can have, if I'm using this F shape, and I'm just doing it backwards, then I'm going to wind up with corresponding angles that exist here and here. If my F shape is upside down and backwards, I'm going to wind up with corresponding angles that are here and here. And if my F shape is just upside down from the original one, I'm going to wind up with corresponding angles that are here and here. So those are all 4 different possibilities that I can have. Let's call this B and B. This can be C and C. And this can be D and D. And we know that they're all going to wind up matching up. If I'm using corresponding angles and straight line angles to calculate the following, well, here I can see that there's my F shape, which means that the 120 degrees is going to be the same as my A degrees. So A degrees is going to equal 120. I also know that A and B are going to create this straight line, which means that B degrees is going to equal that total of 180 minus 120, or B is equal to 60 degrees. If I go to the second example, I have my corresponding angles making this F are going to be the 124 and C, which means that C degrees has to equal 124. Going the opposite direction, I can see my other corresponding ones are these backward f here, which means that 132 and E are also going to be corresponding. I can see that C and D make up a straight line, which means that D is going to equal 180 minus that 124, or D is going to wind up equaling 56 degrees. And I know that F is going to make a straight line with E, so F is going to equal 180 minus 132, or F is going to equal 48 degrees. All right, the second case, so that's corresponding angles, they make that F shape. We can also have alternate interior angles, which are going to be a Z shape. And you can think of it as a Z or an S. It's going to work the same way, just flipped. The Z in the diagram is made by two parallel lines, here, and it's transversal, which is cutting through both of them. If we extend two of the lines, we make an X and have two equal angles that are opposite at a vertex. So if I extend the line down here, extend the line over here, then I'm going to wind up with this X shape, and I know that these two things have to be the same. At the same rate, if I know that this is 50 degrees down here, I'm going to have that backward F for corresponding, and I know that A is going to have to be also 50 degrees. Which means that if I have that Z shape, then those two angles are going to wind up being the same. So in this case, they're both 60 degrees. When I go for my second one, it's just going to be a rotated Z, and I can see that this is going to be 40 degrees, and this is going to be 40 degrees, which means that they're both 40 degrees, and they match. And for the last example, this angle is going to be 105. This angle is 105, and they're both 105 degrees, so those ones match. So, any pair of parallel lines makes a Z shape with a transversal that crosses them, noting that the Z shape can be backwards or upside down, so we can keep rotating it like we did with the F shape. And the angles marked A are equal and called either alternate interior angles or just alternate angles. So anytime we say alternate angles, it means inside of that Z shape. On the diagram, mark any other pair of Z-shaped alternate angles and label them B. Well, here and here are going to be the other Z shape. If I am using alternate angles and straight angles to calculate the angles marked by the following letters, well, the first thing is I'm going to look for where are those Z shapes. And the first one I have is going to be in here. And I can see that from that, this angle and this angle are going to be the same. So I can say right away, B is going to equal 69 degrees. I'm looking for the reflection of that, and I'm going to see the reflection of the Z shape right there. And I can see that with that, this angle and this angle are the same, which means that A is going to equal 47 degrees. Because this is all going to make a straight angle when I add B, C, and A, then I'm going to say that C is going to equal 180 minus 47 minus 69, which means in this case C is going to be 64 degrees. Now, when I get to example B, I can see that I have my two parallel lines are going to be here and here, and there's the transversal that's going to give it the Z shape that I'm looking for, which means that when I look at this, I can say that, well, the 42 and the D are going to give me that Z shape or the alternate angles. So D has to equal 42 degrees. The other thing that I know from what we learned in the last lesson is here, if I have the double dash here and the double dash here, it doesn't tell me they're parallel, it tells me that they're going to be the same length, which means that if these two are the same length, then this angle has to be the same as this angle, and we can call those both E degrees. Well, if the entire triangle is made up of 180, one of them is 42 and the other two are the same, then I'm going to say that E is going to equal, if I took 180 and I subtracted 42 from that, and then because the other two are both going to be E and are going to match up, I divide the result by 2. Which means that E is going to equal 69 degrees, which would be the same over here as it is over here. And if I know that E, D, and F all on this side are going to add up to a straight line, then F is just going to be 180 minus 42, which is D, minus 69, which is E, and F is going to wind up being 69 degrees. I also could have solved that instead of using the straight line rule, stating that because I know this is 69 degrees, these two are parallel lines, and here's another transversal, I could have used my corresponding line rules, or that F-shape rules, to know that F and E are going to wind up being the same.